Okay, so today we took notes on finding an equation from 2 points. This is very similar to what we did yesterday, so I'm kind of going to roll this in for both today and yesterday's notes. The part that was new today was just the initial step is finding the slope. So for this type of problem, we are given 2 coordinates. So in this case, the first example from our homework tonight on November 2nd was we had the coordinates 1, 5 and 2, 7. The first step obviously is just read the problem. That's not even really a step. But the first step we're actually going to do to actually get us started solving the problem is we have to find the slope. Now there is a way to do this algebraically, which is to, you can either graph it, as we have done here, graphing it. Of course, this is something we are used to. We know how to find slope given 2 coordinates. All you do is when you plot them, you will find the rise over the run and put it as a fraction and simplify it. So the slope will be 2. There is another way. You could simply find the difference in the y value and put it over the difference in the x value. So in this case, we could do 5 minus 7 and put that over 1 minus 2, and we would simplify this whole thing and we should get the same answer. This is just the second way to do it. If this is messing you up, don't do it. This is just a second way that you could solve it. But graphing is going to be more straightforward, and it is something we have already done and you should be more used to. So by all means, do this for step 1. Put it in a graph and find the slope. You will be needing the slope. After you find the slope, the rest of the problem becomes the same as yesterday's work from November 1st, which is first, you need to plug everything into slope-intercept form, y equals mx plus b, where m is the slope, b is the y-intercept, and the x and y are just an x and y coordinate that we've had. So, for example, I took this equation, y equals mx plus b. The slope we got was 2, and the coordinates we had included 1, 5. That is 1 comma 5. The 1, if I have a set of coordinates, 1, 5, the first number is always, it always has been and always will be, my x value. The second one is and always will be my y value. So when I'm plugging this in, that 5 goes here for the y, that 1 goes here for the x. And then I just plug this in, and then I go through and I solve trying to find the letter b, which is my y-intercept. We go through, we do 2 times 1, we subtract 2 from both sides, and we get 3 equals b. The final step is we have to put this in slope-intercept form. So all we are going to do is for my slope, we're going to put the 2 back in because that was my slope. And for the y-intercept, the letter b, we're putting in positive 3 because that's what we got. That is the entire process. It doesn't really get any harder than that. The only thing that is kind of hard that I've been noticing some of you guys struggling with is figuring out the slope. So this is just number 1 from our homework tonight. Our homework, of course, being... Oh, wrong assignment. Our homework being this. So as you can see, question 1 involves the coordinates 1, 5, and our answer was 2x plus 3. So I just go through and look on the top half of this paper until I find 2x plus 3. It looks like it lines up with letters D, E over here. So that's just number 1. Number 2 and a whole bunch of the rest of the problems are solved exactly the same way. Let me scroll over so I can show you number 2 and you can see how condensed this work can actually be. So for question number 2, step 1, I needed to find the slope. Here it is algebraically if you prefer, but finding it using a graph works just as well. We have our point at 0, 1 and another point at 3, negative 8. Rise over run, we went down by 9 units and we went over by 3. That gives me a slope of negative 3. Once I have my slope is negative 3, I'm just going to take my slope and plug it in for m. So negative 3 goes here. And I'm going to use this coordinate because these numbers are smaller than those numbers, it's generally easier to use smaller numbers. So my 1 is my y coordinate, that goes here. And my 0 is my x coordinate, that will go here. Then I just solve it. Once I go through and I solve this problem, I should end up with 1 equals b. So that just means that when I'm plugging in my equation, my slope will go here, and my y-intercept will go here, which would give me y equals negative 3x plus 1. That's my answer to number 2. For number 3, yeah, your homework tonight was really just the last 5 problems. The first 5 I went ahead and did with you guys. So once again, we're going to find the slope between these 2 points. Finding it graphically, pretty easy. It fits in this nice small graph. We went up by 1 and we went over by 2, giving me a slope of 1 over 2. When I plug in my slope, 1 over 2, I'm going to, once again, just use this first coordinate because these numbers are smaller. And my x value goes here, y value goes here, and my slope goes here. I'll solve it by doing 1/2 times 2, which gives me 1. Subtract 1 from both sides to balance out the equation and isolate the final variable, and I get negative 4 equals b. So negative 4 will go here, and my slope will go here, which gives me y equals 1/2 x minus 4. And you can see I tried color coding this. The slope goes there, y-intercept goes there every time. Let's go ahead and do another problem. Number 4. For this one, very similar. We once again have 2 coordinates. We find the slope. The slope this time we went down by 3 and over by 2, so negative 3 over 2. It is the same as if I did it graphically, okay, or algebraically. Then I just take my slope and plug it in to my equation, and I work it out using this coordinate. I simply put the 5 over here and the 2 over here, and my slope over here. I solved it as per usual, and I got 8 for my y-intercept. I plugged it in here, and that's my answer. The last problem, I did something ever so slightly different. See, the last problem, all those times I keep using the same coordinate. This time I used a different one. So for this one, once again, I found my slope. We went over by 2 and up by 8, so 8 over 2, which gives me my slope of 4. I didn't even write it out algebraically this time. This time, once I have my slope, which was 4, I plugged it in. But this time, my second coordinate has the smaller number, so I'm just going to use it. It doesn't matter which of these 2 coordinates you use. You can use whichever one you want, as long as you use both of those numbers or both of those numbers. It doesn't matter. So I went ahead and plugged it in. My x value replaces my x, and my y value replaces my y. And my slope obviously just replaces my m value. Multiply 4 times negative 1, that gives me negative 4. Add 4 to both sides to isolate it, and I get 7 equals b. Which means when I'm going through and solving this, y equals mx plus b. I have y equals my m, which is my slope of 4, x, and then plus 7, because it is a positive 7. That's it. That is the entire process for solving these types of problems. And incidentally, there is now a video proof that I have gone over this with you guys already, at the very least, for those first 5 problems. The rest of your homework is to do that same process with these 5 problems, and you have an answer key over here as well. So that is going to do it. I hope that this video helps. I hope these notes help get you caught up, those of you who have been absent. And just as a reminder, if you were absent both Tuesday and today, both on the 1st and the 2nd, the only thing different about today instead of yesterday, yesterday's homework and yesterday's class was all about just using the slope if we have it already and one of these coordinates. So if you can do this using 2 coordinates, You can definitely do what we did yesterday because it is just an easier version of what I'm doing now. But again, hope this helps and good luck.